solve the problem.
Okay.
Houston,
All right, Steve, good job.
Okay.
You're quite the engineer.
Well, you know what? When you fly to Mars, you need to... Okay, so I'm just going to put them on mute. Okay.
Okay.
Oops, there we go. And Mr. McNulty is on mute. And Garvin, I'm going to put him on mute as well. Okay, so now hopefully they'll be able to hear you and me as well. All right, so you're obviously working in a place where, you know, space and exploration is very exciting, and there are lots of new projects on the go. But because this is a Humans to Mars Summit interview, obviously Mars has become the flavor of the month. Movies are coming out left, right, and center. Everyone's talking about getting people to Mars, but it's not that simple.
Well, Mars, Steve, if I may just put it in context, is a forever beguiling place because it presents itself with all the right stuff, kind of like Mother Earth. But then it tricks us, you know, like a good detective novel, into presenting things that can be confusing. And we've seen Mars as a polar, sterile, cold desert to an ancient, warm, wet, fuzzy place as we've gone through our exploration. So putting women and men on Mars to see and feel and experience that other world that was never Earth is, you know, it's kind of like nothing we've ever experienced here on our planet in exploration. We've sailed the seas and traveled the lands and gone to the poles, gone into the atmosphere, but never experienced such a transformative opportunity. So it's in the hands of knowledge and engineering to bring that Mars to us so we can go there. And we're ready to that task. And that's why we want to see women and men go to Mars so compellingly, to make those discoveries we think Mars will present for us in ways that will forever change how we see life in the universe.
When do you think we will get to Mars?
Well, I guess I like to tell everyone, we're there. Every day we wake up to see the new Mars rising from Curiosity, from Opportunity, from orbiters like MAVEN and Mars Express and Mars Reconnaissance Orbiter, and now the Trace Gas Orbiter from the European Space Agency in Russia. So we have a presence there second to any place except understanding our own Earth. So that's pretty good. We've come a long way, baby, as they say. And so now we have to put the dots together to get the engineering right so women and men can go there safely and actually come home if they want to. And that's a critical part of the step. And it's farther and harder than the moon, which is why the moon is a great test place to put people, women and men, to explore. But the questions Mars raises, you know, they're sort of humanity's longest questions. Are we alone? Where are we going? How do things change? You know, what makes our solar system unique or not? And they're all there at Mars, particularly as we compare to Earth. So our job for everyone is to get the people of Earth there beyond our vicarious presence we now have, to be there ourselves someday. And I think that's within reach, and the engineers have done amazing things. So let's let them have at it.
Okay, so I'm going to give Mr. McNulty's group a chance to ask some questions because I know that they have to leave at some point. So if there are any burning questions you have about Mars, let's have it.
Camera's up there. This is your mic. Be nice and loud.
All right, I'm Dylan Kavanaugh, and wanted to ask what physical preparation is needed to travel to Mars?
Okay, did you get that question, Jim?
I only heard parts of it. What physical preparation
is required to get to Mars?
Yeah,
well, let's remember some things about Mars. You know, if you went there today, our life systems, our human bodies would not do too well. There's no air to breathe, no water to drink, no food to eat, an oxidizing radiation environment that kills most things pretty quickly, and it's very, very cold. I like cold weather personally, but you know, it's the Stanley Cup playoffs, it's hockey time, but it's a lot colder on Mars. So Mars was not designed for humanity as we live here on beautiful Earth. However, that said, people have gone to space, living in the International Space Station, been on the moon brilliantly, and so that Mars environment that we're now measuring can be technologically made available to humanity. And today our machines, our rovers, our orbiters are handling that environment. So to prepare the way, we need to know, what are the environments like? You know, what do we need to bring ourselves to go there? The same way scuba divers go into the water with their own air and timers and things. So we need to bring with us the water we're going to use. Someday we can probably live off the land on Mars, but not until we prepare that way. There may be plenty of water buried in the Martian ice sheets under the ground, but accessing them and using them safely will require attention to both what's in them and also planetary protection. We don't want to contaminate those with us, where there could be Martian microbial systems living. So preparing the way is the job of our robots, and we're learning so much, but there's some more steps we need to take. Where is the best water? Where are the safest places? Are there refuges that we could use? Where could we get the best energy delivery from the sun on Mars so people can have the energy they need to communicate with Earth, keep alive, and all those things? And these are engineering details that engineers here on Earth love to tackle. They're ready. We just have to give them the momentum to keep going so we can do that. And last thing I'll say, Steve, and colleague who asked the question, one of the key steps is a robotic round trip to Mars. And the science community want it, the human exploration community want it, and the engineers want it. It would be great for everyone to have Martian stuff here on Earth collected with that purpose in mind. So for generations, we can pour over it as we go ourselves.
Okay, well, that's a very good answer. I noticed that Dondi in Hungary wants to know how long, it says, how long can a food be eaten? So I'm assuming she's talking about, you know, if you're going to go to Mars for a while, you would need to preserve food. So I know on the ISS and various rocket missions, they take food that can last a while, that has a long expiry date. What sort of, would we be looking at new hurdles here if we were going to Mars?
Well, at NASA, and I should say the world community, we have nutrition dietetics experts that design space food. I'm not one of those people. So, you know, I would say that the team we have at the Johnson Space Center, in contact with colleagues around the world, certainly from various spacefaring nations, have thought about, so what would the people need for nutritional sustainability in space? And so we're designing systems on the International Space Station that astronaut Kelly experienced during his 1 year on orbit, experiencing what might be the fastest possible round trip to Mars, if people ever were to take that trip, to see what we need. And eventually recycling air and water and even potential aspects of food as we go on long trips into deep space will be important. And those are the steps to make available that Mars frontier. So when we go, we'll go with the tools to live there well. The other thing is to learn to live off the Mars land. There may be sufficient resources on Mars to give us the water we need to grow, as the film The Martian depicted rather engagingly with Matt Damon, to grow the food we could use while we're there. It does depend, of course, on how long does it take to get there? How long do we want to be there? How fast do we want to come home? What things do we want to do when we're there? Those are the kind of, you know, what do you want to do when you live on Mars kind of thing? And people have been thinking about those for the last 25, 30 years with lots of really exciting opportunities for women and men to do powerful things there. So the food matters. Some of our best women and men are on it, thinking about the space station as the bridge, maybe going back to the moon to learn more as we then prepare for that Martian frontier. Does that help?
It certainly does. I mean, I hope that answered the question, Dondi. Ms. McNulty, does anyone else in your group have a question they want to ask? Yep, I see a hand up.
Yeah, right here. Introduce yourself.
Hello, I'm Sebastian. I was just wondering how much fuel and like resources in general would it take to bring someone, like a person, to Mars?
So that question is great. And let me just give you the viewpoint from some of the best mission designers I've ever known. We've been working on this for years, and there may be ways to do better. And that's up to you guys, you smart kids that are going to help carry this frontier forward. So the first thing is the amount of fuel, air, water, and stuff, the gear that people need to live in space, to go to Mars, is about round trip the mass of the International Space Station. So think about that. The space station is soccer fields big. It allows people up to 6 and or more to live and work in space at the beachhead in space, barely, a few hundred miles away. Mars being on the average 100 million miles, 150 million kilometers away, is a longer trip. So we need the energy and resources, the consumables to go. We need the protection from space radiation that does not exist at the space station at the level it does in deep space. And the last woman or man to go to deep space was in 1972, experiencing that full-bore galactic cosmic radiation and space radiation from the sun. So much of those first trips to Mars will be the consumables to go and come home. The rocket fuel, whatever type we use, whether it be the methane types or the beautiful high efficiency liquid oxygen type systems that we use to launch off Earth. It'll be the fuel, the water, and recycling the water as we go and live in space, critical. And we're experimenting with that on the space station to get ready for those trips. And then once we get there, the first trips may require us to bring all of our own stuff. We may not yet know enough to live off the land of Mars well enough. So while we're preparing the way for that, we have to also have a backup. You need a backup plan. I mean, if you go and forget your suitcase, you want to have something else, you know. That was a joke, but you know what I mean. So a lot of stuff to go. Now we can use robotic cargo systems to emplace what we need, so when we get there, it's there, and set them up before, so we're not arriving to, oh, now what do we do? It's a different approach than we took with Apollo and the moon, where we brought it with us and took it home with us. And Mars is far enough, we may want to use those kind of pre-provisioning styles like was used to explore the polar regions back 100 years ago. And so, but brilliant engineers, scientists, mission managers are designing ways to do that the way we had to design things to make a rover operate for over 2,000 days on Mars, like Curiosity. So I'm sorry these aren't short answers, but there's a lot of detail and a lot of smart people are thinking about it. You know, you can't just fall into Mars and say, oh, we're there. You also have to enter the atmosphere and go through a massive, perilous descent that, you know, is not unlike returning to Earth from the space station. And those are challenging physical, let's put it this way, it's not as easy as it looks like on Star Trek. And because they've simplified the problem, so we're worried about other things. I love Star Trek. So Mars is hard, but it's worthy, and we can do it. We know we can. We're learning how with space station, maybe going back to the moon as part of the step to learn some of the things, and experimenting here on Earth in analog environments to see what it would like if you had a Mars-style expedition. Does that help?
It certainly makes sense to me. But now, of course, you were there at the beginning when we first started sending rovers to Mars. What was the first implement or device that we ever sent to Mars?
Well, the first missions to Mars were flybys, little robotic spacecraft that flew by. And then we had our first orbiter that was successful, mapping Mars with Mariner 9 in 1972. Wow.
That was a long time ago.
And that mission sort of gave us the first view of the exciting Mars that reminded us that what we had seen from telescopes on Earth looked cool, dust storms, you know, scratchings that looked like canals. And then we flew by initially with the early Mariners, and they didn't look as enticing. It looked like the moon at weather satellite resolution. Then we got with Mariner 9, and that opened the door for the big push to Viking to bring biological experiments, you know, looking for living systems on Mars in the soil. Now, we now know that's probably not the easiest place to look. It's been baked and cooked by space radiation, ultraviolet radiation. You know, most things don't like that on Earth. But that said, we learned a lot. So our first mission that mapped Mars was Mariner 9. We then landed the 2 Viking laboratories in 1976 with the associated orbiters. And for the next 5 years, they rewrote the Martian textbooks. And they pushed us into this reacquaintance with Mars that picked up again in the 90s with the missions like the Global Surveyor, Mars Pathfinder, and then, of course, the missions we have in our new Mars program with Odyssey and the Opportunity and, you know, Mars Reconnaissance Orbiter and all the others culminating in Curiosity and Maven now, and of course the European Trace Gas Orbiter. So a lot of action at Mars, opening that frontier so other players can get involved. The mission from India now at Mars, MOM doing a great job. Trace Gas Orbiter getting ready to do science. Mars is a happening place.
Apparently so. It's the hot and happening place. But I mean, we've discussed the difficulties of getting there. There's obviously the radiation, the duration of the trip, making sure you've got all the resources to take with you. But what about the vessels themselves that are taking us there? Are we at the stage where we are going to be able to cut the journey in half with new rocket engines? Because when I interviewed John Connolly recently, he mentioned that his next door neighbor happened to have developed a new rocket engine that they were testing, and this could be the next big thing.
So getting to Mars is a problem. I mean, we can't violate the laws of physics, and the Mars-Earth geometry is a nifty math engineering problem for all of you watching. And you can look at that math and see that there's a cycle of arrangement that allows Mars and Earth, leaving Earth to get to Mars with the least energy in the least time. And you can change that number with better rocket engines or more creative approaches once you get there to get into the Mars system. You could use cargo vehicles using the energy of the sun to carry more heavy things there so they don't have to go with the people, separating the crew from the cargo to allow us to do more. And as John told you, breakthroughs in rocket engines, including the idea of eventually getting to nuclear electric kind of propulsion or nuclear thermal, could change the trip geometry as well. And we studied, and John was part of it, we studied 15 years ago, different architectures to do a round trip to Mars with people in about a year or so. They're very energetic. They require a lot of fuel and not a lot of time on Mars, but they give you a first taste as one option relative to the 3 or 4 year option, which gives you more time on Mars, which is more attractive. And these are the choices engineers, mission designers, nations have to make. Do we go for a short visit to get to know it? Do we go and leave behind a lot? Do we go and live there the first time? And they're all good. So new advances in propulsion, critical. In-space propulsion has not been revolutionized since the 60s and 70s. We're ready, as John told you. In-space power delivery, in-space information technology that changed the way we do things. All these revolutions are ready to impact how we get people and robots to Mars.
I mean, I'm thinking of one crazy South African in particular who might just be able to pull it off. And that, of course, would be Elon Musk. Do you think that he has the potential to come up with a new form of jet propulsion that could get us to Mars in less than 30 years, which is the projected arrival date?
Well, I think Dr. Musk's team at SpaceX and doing a fantastic job with cargo and developing systems, to return vehicles has been great. This partnership with industry and innovators is going to open the space frontier. How it applies to Mars depends on which part of the trip that can be tackled first. We get there through the laws of physics, and those transfers require Mars-Earth geometries and trip times and cycles. Every 26 months, there's favorable geometry. Every 14.7 years, there's even better. These things are the laws of physics, and I think Elon Musk and other great colleagues like him in the new aerospace industry, Jeff Bezos and others, have nifty solutions, as does NASA with the Space Launch System, put more mass into space for eventually crewed missions wherever we want to go. So these things together are going to solve the problem. The other big issue at Mars is once you get there, you got to stop and get into the Mars system. It's not like gently lopping onto a beach on a boat. There's kind of a several kilometers a second of velocity to get rid of slowly so people can make that transition. The same way the space shuttle came back, or the Soyuz vehicles come back, or the new Orion crew vehicle will. Those require material science, smart, autonomous software systems that respond to changes that are dramatic. And those things need the collective wisdom of everyone. And I think Elon Musk is adding to that wisdom. I wouldn't be surprised if he wouldn't be able to in place robotic assets soon that would help us do more at Mars to open that frontier, maybe together with other partners, including NASA. I think Mars is a good draw for the world community to do great things in space, as been terrestrial remote sensing and weather and all that kind of stuff. So again, there's a new future out there, and we're just starting to see it. And I'm excited by it. It's going to be great.
Well, I'm excited that you're excited, because if someone like you is excited about it, it means that, you know, that you're obviously in it for the long haul. You have a personal interest in it. So that means that if there's excitement, you might even know about things that you're not even letting us onto yet, because, you know, you can't obviously declare everything out in public, and perhaps you're even working on some interesting projects that might in the next couple of years come to fruition. But I want to know if Mr. McNulty's got any more questions with his students before they have to leave at some point. And then maybe Govinder in Nepal, you might want to ask a question, and Dondi in Hungary, you're welcome to ask as well. So let's see what Mr. McNulty has to say.
Go ahead, introduce yourself and go ahead.
Okay, so my name's Ashley, and what are you gonna protect the astronauts with? Because I know there's gonna be dust and sandstorms on Mars, and it's gonna be super cold. So I was just wondering how you are thinking that you're gonna protect the astronauts from all that.
Okay.
So great question.
This is a great question.
People like you, women and men, are going to need to be protected from Mars. And there's sort of three things we need to protect, and the spacesuit engineers and the human spaceflight engineers, including the medical doctors that assign risks to how well people would do under different, environments, have all been thinking about this for a long time. Way back to Apollo, when people went to the moon in the vacuum of space. So the first thing is we have to have temperature regulation. The surface of Mars averages tens of degrees below zero relative to how we live here on Earth, at 20 degrees C. So we have to have a thermal regulation system so we don't overheat or overchill. And spacesuit systems have been designed to handle that. And they're being developed in the United States and Europe, I'm sure around the world everywhere. I don't know all the places. Secondly, we have to protect against what is probably nanoscale Mars dust finer than a millionth of a meter. And that spectrum of dust we're just learning about scientifically. That could get into everything. The suits, the fabric, the filters of the air we exchange with the Mars atmosphere, all these things need to be solved. And they're science, engineering, technology problems. And that partnership, engineering, science, and technology, works together always to solve problems. So those are being addressed. We're measuring the distribution of dust. Dust so fine it would make you sneeze and other nasty things. Finally, there's space radiation. The Mars magnetic field is gone. Now, how does a planet lose a magnetic field? It's an interesting, good question. But Mars lost its. And so it is not protected from that maelstrom of space radiation that our surface planet does not see. It's naked in the breeze of the solar wind. That's a pun. But and so we have to protect against that and be ready to respond to solar storms that could reach Mars in a couple hours from the sun, and that would literally cause medical challenges to human explorers. So we'll need safe havens, refuges, need to build systems that allow us to protect for those things. So we have to handle a lot of problems. There may even be toxicity issues with the Martian dust and rocks, and even the Martian ice, which could be converted into liquid water. So we need to measure those things now, so when women and men get there, and I believe they will, and they'll do great, that we're ready to tackle them with our eyes wide open, because the Mars system is too interesting to have our eyes wired shut.
Okay.
Does that answer the question?
Which is a good question. Good answer. Good answer. What I am interested to know about is the dust. So John mentioned that the dust storm, and you just alluded to now that the dust is so fine that when there is a dust storm, you would hardly even feel the dust actually coming at you. It would almost be like less than a light breeze, and nothing like what we've seen on the TV programs and the movies that portray these Martian dust storms. But what you have indicated is if they are so tiny many microns small, then most standard equipment that we use to filter dust and things out would not be adequate to deal with that kind of dust. And as you said, that would cause a whole range of other problems, breathing issues, and instrumentation. Are they equipped to handle such fine dust, to keep it out? I mean, the camera lenses, I mean, all those sorts of things. I mean, how have we managed to survive, how did the camera lenses on Curiosity and all of them survive with all that fine dust there? What have we learned from that?
So Steve, and John's point and your point is right. The movies depict Mars in a humanly connected way relative to Earth. But I like to remind everyone watching, Mars is not Earth. It had its own history. And so we have to step back from our beautiful planet and see Mars for Mars' sake. And so Mars never read our textbooks, doesn't care. It grew up its own way, so we need to live with the real Mars. So the first thing is, the surface atmospheric pressure and density of the Mars air, dominantly carbon dioxide with some nitrogen and water vapor, and other trace gases like methane, is on the order of 1/300th that of Earth. And simple physics you can do in your physics textbook in middle school will show you, if you blow that air over things, it's not going to knock over, 100-pound kids or 300-pound football players. You wouldn't feel it. And secondly, if that air is moving along at tens of meters a second, maybe 30, 50 meters a second in a dust storm, with lots of dust involved, dust that's finer than a millionth of a meter, submicron stuff. You wouldn't even see it without a special microscope or a scanning electron microscope. What would that do to you? And those kind of physical interactions are the ways we have to think out of the box. And that's why I think the kids of today, you guys that are going to go and feel all this, you're going to tackle these problems. We're going to measure the dust for you. We'll see what it's like, how it sticks together, how it mechanically behaves. But we're going to need to do more to understand that. And so the bottom line is, dust is a big problem, and we need to solve it. Excuse the phone ringing in the background. It's okay. Not Mars calling.
We know it's live. We know this is live. That's how it works.
So anyway, I guess my final point about this is, all these little problems are part of a mosaic of solutions. Dust, radiation, temperature control, landing safely, living off the land, getting off the planet to get home. One of the ways of solving those is to do robotic missions that allow us to get rid of some of the risks. A robotic sample return that collects dust and rock chips or whatever, brings them back to Earth to allow all the engineers and scientists of this planet to study them, will change everything. And the community's been saying that since the late 70s. We're ready to take that on now and bring that stuff back. We can also use the meteorites that Mars has delivered to us. But we need to look at the dust and the volatiles and the air and all that stuff together so we can get people there with their eyes wide open.
Okay.
Is that good, Steve?
That is great. We love your answers because, you might think that you're going on and on, but you're giving us, the whole gambit of what to look at. I think sometimes people just give very simplistic answers and you think, well, they didn't really give me the texture that I need, but you're giving it all, and we love that. Dondi, do you have any questions that you might want to ask? We have Dondi in Hungary. If you okay, she does have a question. She'll just undo your mic. And Garvin in Nepal, if you've got a question, you want to think about one?
Yes.
Let us know.
Yes. As you know, I am a woman. So if there will be men and women on Mars, are there going to be next generation? And how long can it be circulated?
I'm not sure. Yeah, that men and women, will be going to Mars, and then?
And there will be men and women, and they cannot come back because of the time and other problems. What about the next generation?
Okay, I got it. Jim, did you get that? So Donnie was alluding.
I did quite follow, Steve.
She was alluding to the fact that obviously if we're going to be sending men and women to Mars, and they're going to be staying there and not coming back, and we're looking to build a new colony, whatever it is, we're going to be looking at producing the first Martians.
So, I mean, I think that's a marvelous thought. Right now, we're thinking, even before that, just going 1 or 2 times and coming back. And those aren't the colony building steps. Those are the opening the frontier steps, the first touch with women and men there. And whether they go for 30 days or a year and a half, those first visits will open our eyes to how to live and work on Mars effectively. We don't want to go and be stuck, locked inside a little, habitat, worrying the whole time. We want to interact with the real Mars, ask questions, drill, live off the land, establish a presence that can become sustainable. Then we can worry about colonizing and sustainable developments, which will come. And they will come to the peoples of this planet when the time is right. And as they did in colonizing our planet, going across hundreds of thousands of years of early hominids. So I can't tell you how that will play. I can tell you that those first trips by the people of this world, the women and men, they will set in motion what will happen then. And one thought is those first trips will just leave behind enough to see how Mars works when people are there. And we'll read that record and say, okay, here's a nifty new solution that will let you live longer and maybe start to become transgenerational. I mean, one thing we can do is put a microbial laboratory there and watch multi-generations of microbes live and do their thing on Mars, react, evolve maybe, and then measure that biologically, microbiologically, to see, okay, how's that going to affect us when we're there as bigger, more complicated systems? So there's a biological aspect that the astrobiologists of the world and the medical biologists are starting to think about in space. How do we express ourselves in space as a living system, as a system of systems? So the bigger question of colonies, great question. I'm not equipped to answer it, but the near-term question of just understanding how life works from Earth on Mars is something that we take very seriously. Lisa Pratt at NASA is our Chief Planetary Protection Officer. It's her job to worry about that, both us affecting any Martians if they're there, microbially or whatever, and also affecting how we exchange life back with Earth. So this is a very serious, important topic as we go to new places. We want to leave them for them, not for us.
Okay, great answer. And then I know, Mr. McNulty, you've got one more question before your class has to leave.
Yes, middle schools, tight schedules, we're here training astronauts for you. There go bells and stuff. But come on up. Okay, we have one more question for you before we have to go. Go ahead.
What type of food do you eat on Mars?
You're going to have to say it a little bit louder.
What type of food do you eat when you're going to Mars?
What kind of food do you eat when you go to Mars?
Well, I mean, food is important to us all. I mean, we're a culture that enjoys what we eat, and that's true. Space food has been designed over literally 50 years since Apollo, and we have experts who design the foodstuffs that will probably be those which go to Mars. And right now, a lot of them are, and it's not my field, so I'm just really describing what the experts do at the Johnson Space Center in Houston and in the industry that supports that, and in the space medical field. But nutritionally useful food that allows for health and well-being of crews have been designed. They are approved by the Dietetics Institutes of the planet, and they will allow people to live and work well in space. And they've been tested on the space station, and new generations of them will be tested on the Cislunar Gateway that we're talking about developing now, across the nations of the world, and hopefully back on the surface of the moon. So we have lots of varieties, food that is freeze-dried, that is reactivated with water. There are foods we could grow ourselves. We've been growing plants on the space station that have been cultivated now, and actually harvested. I think recently an experiment just harvested plants in space, grown on the International Space Station. So what we actually use for Mars will be designed by dietitians with medical doctors. And I think they'll be palatable. And Scott Kelly and his experience in space can describe what it was like to live a year on space food. Probably should ask him better than I. I haven't enjoyed that experience myself. But trust me, smart women and men who design these things are thinking about that problem, whether it's a 1-year trip, a 3-year trip, whatever. And that's, you know, that's part of living and working in space. How we do it, you know, all the things matter, including food.
One thing I can be certain of is we've had a couple of astronauts out here in South Africa, and we've taken them around to schools, and none of them were speaking about the highlights of the foods that they took with them on their journeys, because they said that the food that you get is there to be eaten, but it's not there really to be enjoyed. Sometimes an astronaut will bring something on board, you know, if they have a supply ship that brings, you know, maybe some tacos or maybe some cheese or something. But in general, it's freeze-dried food that you add water to, and I can't imagine that is a gastronomic delight to look forward to. But I can tell you that when they all come off the space rockets, well, the first thing that they can't wait to do is eat a proper food like pizza and that type of thing.
I guess the answer is you don't go into space to explore for the first time places as hard as Mars for the food.
No.
I mean, you know, notwithstanding the pleasures of food, that's probably not the reason you're going. And so, you know, I would just say our dietitians, I'm sure, are doing the best job they can with limited available mass and water and, you know, systems to make the food palatable. But nonetheless, we do care about that. And we all want music in space too. Music matters. So, you know, we need to bring our own favorite tracks and keep stimulated by music and other forms of the arts that will keep us going on these trips. And these trips will not be short. You know, if you've been in a car for a year driving somewhere, you know, think about that in space without contact, quite the same bandwidth with home. That's how those trips from Mars will be. But nonetheless, unbelievable.
Awesome, awesome. Now, I know that Mr. McNulty's group are going to be leaving, so we'll say goodbye and thanks for joining us. Bye-bye, everyone.
Bye, everyone. Thanks.
Thank you.
And we've got quite a few people who've joined us live around the world who are actually watching this and streaming it live all over the world. So thank you to all of you that have joined us as well. I'm just wondering, we've got Govinder in with us as well. Govinder, do you have any questions you want to ask out in Nepal? He hasn't responded yet. If he does, maybe he wants to just type it, or he'll just let us know when he's ready to ask a question. And then I noticed that, Dondi, you asked another question, and your question was, what is the best age to travel for a human and why?
What was I missed it, Steve?
The best age to travel. So if you were going to send someone to travel to Mars, and someone wanted to be an astronaut traveling to Mars, what would be the optimal age to send?
So I really have to say, as a geologist, I have no idea. I think there's a room in space for people from the youngest women and men ready to go to people that have trained well enough to show they can operate in space effectively for the challenges, you know, in greater age ranges, in their 50s and 60s, for example. And John Glenn flew in, you know, up to his 80s. These are questions for the space medical doctors. Colleagues like John Charles at Johnson Space Center has a checklist of things you need to be an effective space explorer and that you need to be protected against. And there are protocols for making those selections. Some people are better at the kind of psychology of being in space on long trips. Others are wonderful innovators with challenges, as the Apollo 13 crew showed with Commander Lovell and his team that brought back that challenged mission. So those selections are very important. I look at the people I've known that have flown in space, my friend John Grunsfeld. I can't think of anyone better. Sally Ride. These are the kind of folks that we want, Kathy Sullivan, for example, that we want to fly in space. And they're from all over the world, and they'll be ready to take on the challenge. What age is optimal? I think it'll be a biomedical, psychological choice by experts. And we we rock doctors are more worried about what they'll be touching and exploring when they get there, and how they communicate it back to us and all that. So there's room for everyone to go once we build the systems that open up that frontier.
Well, since you've been mentioning that you are a geologist, I don't know if you know my friend Ellen Stofan. She's also a geologist as well. And you obviously are curious about what they're going to find in terms of microbes and that kind of life form on Mars. You might even know information that you're not allowed to tell us just yet, but obviously you guys are exploring the surface and you're trying to pick up whatever you can on that surface. When they do find evidence of life on Mars, that effectively is life on another planet. And we have evidence of that then. How close are we to getting that?
Well, first, I just want to say, Ellen and I went to school together at Brown. We're old friends, and I'm glad she's a good friend of yours. She's a fabulous geologist and now taking on leadership at our Air and Space Museum. So hats off to Ellen. I really can't say enough about her amazing talent. So that's great. I think Mars, offers us the perfect first test case for understanding how to search for life agnostically off our planet. And a colleague of mine who I was lucky enough to work with several years ago is leading an investigation, Sarah Johnson at Georgetown, on how one looks for life without bringing with us the baggage of everything we know about this massive living system on Earth. And so I think the records of life we may discover on Mars will be a little bit more elusive, a little more tricky than the massive expression of life we have that's dominated the geologic record as we see in the rock record on Earth. And so we have to look differently. The Mars life may have expressed and done its thing if it existed in different ways. It's obviously not obvious. What we've done with Curiosity is detect organic molecules for the first time on Mars. From Mars, on Mars. That's a big deal. 25 years ago, that was considered almost heretical. We've seen that there's habitable environments. Places that if you stuck Earth microbes, they do fine. I mean, they may not like the space radiation, but they could bury themselves a few meters down. So my hope, and I have no new knowledge, I'll be honest, my hope and my dream is that we discover a microbial universe on Mars, that our vehicles, our human explorers, the collective wisdom of all those discovers that, and that frontier opens our eyes to the life we can see elsewhere, in the oceans of Europa, in the frozen and not frozen oceans of Enceladus, on Titan, even in the fossil record of oceans on Venus. And this solar system is our cradle, and we need to learn from it. But I think Mars is a good place to ask the question because the records are, I think, could have been preserved in the rock record on Mars of those different times. And so our job as geologists, geomicrobiologists, scientists, is to use the tools and eventually human explorers to discover that possibility. And listen, Steve, and everyone out there, Mars, to me, is a cryo-ocean world. The water story is frozen in the ground and under the ground and in its ice sheets. And the Mars we see today is not the Mars of the high climate times that the climatologists have shown us probably occurred episodically, cycling a long time. And so who's to say when there were Martian seas and big lakes and Gale Crater that there couldn't have been a possibility of some expression of this fantastic biology? So I'm rambling, I'm sorry.
No.
My hopes are there. Mars rocks, and the record in the rocks is going to tell us what we need to find, and we have the tools to look.
Now, you're obviously going to be attending the Humans to Mars Summit from the 8th to the 10th of May. Is that correct? And
Right.
And I mean, obviously, every year they have this event, and people gather around to talk about Mars and the progress that is being made. Do you think we're going to have any major breakthroughs in the next, at least in the next 5 years, things that are going to take us to the very next level that we've only been talking about now? And if you do, what might those breakthroughs be?
Well, Steve, I think absolutely. First, we're going to be flying the InSight lander to Mars that will listen to the heartbeat of Mars' interior in ways that I think will be revolutionary. And it may seem esoteric, okay, well, but it's going to give us the insights, pardon that pun, to how Mars interior works, the same way the Grail mission that operated around the moon by Maria Zuber and colleagues showed us that shallow interior of the moon. A lot of the Mars action is under the surface. The ice, the story, the rock records, the energy, the heat flow, and even the seismic activity, the activity of Mars. So InSight will be our next step to probe that. And it's a first step. We need more, as always. Next, Curiosity's not done. She's just getting into the really rich rock record of these mudstones, into the places where some of the preservation potential of minerals, things we can measure with our SAM's payload, can start to read more about the story of the organics. And I suspect that Paul Mahaffey and his team will make major discoveries over the next years. Next, the Mars 20 rover, equipped with even more tools and ways to look under the ground with a radar from Norway, will further show us that subsurface. And finally, an instrument, who wouldn't love an instrument known as MoMA? An instrument known as MoMA, built in the United States and Germany, will fly on the European rover to Mars and actually look for complex organic molecules or their kin from samples collected 2 meters, 6 feet deep. That will be the first basic measurement system potentially capable of seeing signs of life since Viking. So we have a lot to do, and we're going to find a new Mars. Finally, I think we will fly a mission collectively by the people of the world to map the underground ice story on Mars completely. It's within our reach. And when we do that, we will see the Martian water reservoirs are massive, and that's where we got to go, because that's where those records of today's systems could be lurking, and we'll get there.
Wow. Well,
I am so confident and excited that we will be ice drilling and ice mapping and looking in the ice for life like it exists on Earth within the next decade. And my God, who knows what we'll find? I'm hoping the Martians will be waving.
This is very exciting. I mean, if you think about where we were a few years ago and where we are now, we are really at the cusp of making some major breakthroughs. So this is very exciting from a science point of view, from a human point of view. It really is, from a geeky point of view. I mean, I'm just so excited that within the next decade we're going to get a chance to see all of this and actually get to the bottom of some of the answers we've been asking for so long. But I know that there was someone who managed to join the other chat that we are in. He doesn't have a mic, or she doesn't have a mic, but they did ask a question. And I was going to quickly switch to the chat again and see what the question was. It was Daniel. Daniel was asking. And Daniel wanted to know, if you were to build a base on Mars, do you think it would be possible to terraform it to support human life without equipment? That's a tough question.
Well, first, I will just say, as a scientist interested in protecting Mars for whatever Mars offers, I am ethically against the idea of terraforming another world. I think it violates the idea that leave this world to let it tell us about how another place evolved. Mm-hmm. Now, that's my personal opinion, no opinion of anyone else. I think Mars is for Mars, and we need to use that as our window in the universe, the way we use big telescopes like James Webb. But coming back to your question, the energetics of attempting to terraform another world, which has evolved over billions of years, with massive energy systems from itself to something we could live in, is an engineering feat that I find, challenging to imagine because of the timescales involved. Terraforming in a year to make Mars livable for people without a magnetic field, to shield radiation and all these other factors to contain the dust, which is basically the agent that balances the energy in the atmosphere. The radiation balance of Mars is driven by dust, not by water vapor and other aerosols on Earth. I mean, these are unimaginably tough problems. I mean, we can barely do engineering feats on Earth that are pretty amazing. And now we're talking about a whole planet with 150 million square kilometers and its own atmosphere and no magnetic field. I mean, I guess I would rather use Mars for what it is, as a pristine relic of the evolution of something special in our solar system, and learn from it. And then if we need to live there, build the engineering solutions to live there without destroying the Mars we see. And it goes back to Bradbury and the Martian Chronicles, and when you see yourselves, are you the Martians, and all that great stuff. When we go, we will be the Martians of today at the level of you know, civilization that we represent, whatever that is. I mean, I'm not an expert, but anyway, so I would say it that way. Nothing wrong with the idea of terraforming, it's brilliant. But for Mars, you know, I kind of like to rather learn from her or it or whatever she is first before we would do that. So that's my view. And I let the engineers speak because they can mention all the challenges. But anyway, that's one scientist's view.
Okay. Now, I know that Garvin has got a question, but I was just checking with Atalo. Atalo joined us as well from Brazil, and I was thinking maybe he might have a question as well. Atalo, would you like to ask a question?
Actually, my computer, I got in very late, so I didn't hear the beginning of the conversation. So we are formulating questions if possible, but we are getting the grasp of the talk.
Okay, no problem. Right. So they haven't got a question just yet because they only joined late into the actual interview. So I'm going to go on to Govinder's question, and Govinder says, what are the minimum qualifications or abilities to work as a NASA scientist, and how can scientists from different countries get involved with NASA? And then the last question he asked, which is something I would have probably asked you, is what advice would you give to young scientists?
So first, you know, science is curiosity-driven exploration. And so the tools of science come from the techniques, you know, of mathematics and physics and chemistry and biology all working together now in the IT realm too. So there are no minimum qualifications. Curiosity is the minimum qualification. And, you know, I mean, we all should do our homework so we know what we think we know, so we can then ask questions against that. And we're always surprised at Mars and many other places. So as NASA scientists, you know, in the United States, you know, most of us are kind of like, you know, university professors and are training with educational experience at that level, PhDs in the physical and biological sciences, in the computer sciences, math, physics, and we've applied that to the problems of exploring space and Mars. Some colleagues at different levels get involved through internships. Some are experiences at our NASA centers. And we have those programs, and thousands of interns from high school through college get involved. And they do everything from growing microbes under Mars conditions to simulating solar wind, to making computer models of how planets lose magnetic fields, to other great things about the universe. So there's lots of ways to get involved. NASA competes all of its scientific research. So I like to liken it to a sporting event. You compete to be in the, you know, the gold medalists or the silver medalists, and that competition.
It's
you know,
nearly done.
It can be, challenging, but those competitions lead to great science, and all of us have been, you know, been part of it, have reaped the benefits of that. So we have opportunities for partnerships, collaborations, research with NASA scientists at NASA centers like JPL and Goddard and Johnson, and all the others, Ames. And so there's lots of portals into the system to get involved. Where you're doing citizen science, and massive online types of citizen contributions are now growing, not only for Mars, for astrophysics, for earth science. So lots of ways to get involved. I would say if you look at our NASA websites, some of the opportunities are listed, and we can answer questions with more detail than I can say here about the connectivity. Qualifications, curiosity, some determination and tenacity, because you need to learn the tools. I mean, if you're going to run in the Olympics, you kind of learn how to run. If you're going to run in science, you got to learn how to run. But they're not unobtainable. There plenty of room for bright women and men to get involved, and just curious people, because the public of the planet are paying for our exploration. So it's their program. It's not my program, you know, not your program. It's theirs. And so we've generated terabytes of information for everyone, and we want to share it because it's your data.
That is awesome. Now, I know that, Atalo, if you do have a question, you can just wave and let me know. You do have a question. Okay, so Atalo in Brazil would like to ask a question. So maybe he does have one. I don't know. Not yet. Okay. While he's thinking about that, Daniel asked another question, and it was to the effect of, is the gravity on Mars similar to Earth? And would that affect the human anatomy over time?
So the Mars gravity, which is a function of the planetary size, the volume and density of material in the object, is not like Earth's. It's about 40% of Earth's. So if I went to Mars, I'd have a wonderful instant diet and would be a lighter person. Boy, be a nice thing.
I'm volunteering now.
Steve is ready too. Hey, we're all ready to take that benefit. That leads to some questions about biomedical response to different gravity. I mean, the only place people have ever experienced real differences were the short, just few-day missions to the moon, where the Apollo astronauts, like famous people like Jack Schmitt and others, operated so successfully on the moon, some 30, 40 years ago. And that was even less gravity. And they did great. I mean, obviously high-performing science and exploration. So the medical experts who work these problems think that human beings can do well adapting to the hypogravity of Mars, 40% of Earth's. We would feel lighter, hopefully smarter. That doesn't come with gravity. And so it is different because Mars is a different size object. It is a smaller silicate planet, born in a different place in our solar system, went through a different life history. So understanding the distribution of the gravity field inside Mars is a key problem we've been tackling. We would love to send a mission like GRAIL to Mars to probe more deeply into the fine-scale mass distribution. And there's ways with new technologies to potentially do that in the next decade or two. That would be great. But anyway, so we would live and work probably pretty efficiently given the gravity. And certainly at the performance levels that we saw on the moon, which were spectacular.
Wow. Okay, so now, Atalo, we're going to give you a chance. Do you have a question for us? Are we putting you on the spot?
Yes, I would like. We have lots of questions, but the problem is we didn't get the beginning of the interview. So we might end up questioning something that has already been responded.
Doesn't matter.
Sorry.
Ask away. You can still ask. Not a problem.
The question again? Yeah, I don't think we have a question now, but maybe about life on Mars at this moment. If you believe that there was life in Mars, but I guess you already talked about it earlier, so don't worry.
No problem, no problem. Okay, so I'm going to mute you there, and it looks like we've actually reached an hour has gone like this. What I'd like to do is obviously end off with, the advice that you would give to young people. You kind of touched on it a little bit, but in terms of just STEM, science, technology, engineering, and maths, the world around us is changing. AI is coming in. We've got 3D printing. We've got, the turnaround time from taking a rocket to space and bringing it back again and reusing. All these things are escalating the process of doing great science. So is there any advice that you have for the young people today who are now being thrust in a world where everything around them is changing rapidly?
So I guess, Steve, what I would say to everyone, we live in as we always do, in a remarkable time. I would say we're in a system now where revolution in science, technology, engineering, math, even arts are at hand. And so embracing those revolutions as parts of our tools so we can go and explore places like Mars and other worlds, Europa, the universe beyond our solar system. Now's the time. And for the young people out there, you've grown up in a digital age. And I think you're going to come to grow up further in an age of quantum engineering and computing, when what we can do to understand this universe with the information we gather and we compute to understand will change exponentially. And as we come to understand life on our own planet at all scales, from microbes to complicated things like us, I think we'll have a better appreciation of how to look for it elsewhere. and understand what that may mean. Because, you know, we're a point in time on a spaceship hurtling through space. Mars is another one. The rest of the universe is out there, and I don't think we've seen anything yet. So I would say, get involved, be curious, use those tools that you guys have now, because they're better and better and better. I mean, when I was in graduate school, we had 1 or 2 computers for an entire university. And now we have them in our watches and phones and whatever. So take advantage of that. Apply that technology to solve problems like we always do as people. And for you young folks, you know, embrace the side of it that's just beautiful. There's an aesthetic of space. And so that's sort of the intersection of the STEM and the arts, the STEAM, as people call it. And it's there. Mars is a gorgeous story. And let's unravel it together, because I think that'll make it more fun. And collectively, we always do better. So have at it, folks. Mars awaits.
Wonderful. And just one last note. What are your plans for the future? Because, I mean, are you working on anything interesting that maybe you want to mention to us? Something that we don't know about yet?
Well, my plans are, I want to see our Mars exploration continue. And, you know, I've been a part of it my whole life, and I don't think I can ever retire until I see us with people there, the samples back, mapping the ice, and continuing that search for what I hope to be a microbial universe that's recorded on Mars, or at least the record of it. I mean, my God, if we see we're not alone, you know, even at the scale of microbes on another world, then that just opens the door for that universe to explode as a life-bearing place. And I can't imagine that it's not. And so let's learn from Mars to open our eyes to that. Let's extend that to Europa, to Titan, to these other great places. And let's realize that, you know, this is one gorgeous universe. And trust me, as we explore Mars, when that James Webb Telescope starts to push us further into the universe, we will start to be able to play, are there other Marses out there that we need to see? Can we sense those? Because all the other worlds won't be pale blue dots. They may be hot orange Venuses or pale red Marses or other gigantic Jupiters. We don't know. So embrace what's there. And I don't really, honest to God, I wish I had some deeper insight. I don't think we've seen anything yet. So Mars still rocks.
Awesome, awesome. So Jim, thank you so much for taking the time to make this connection work. For those of you who don't know, we had to literally try and solve, I mean, Houston had a problem. We couldn't get onto the Google Hangout, so we've managed to use another program called Appear.in. We're sharing the screen, and then we didn't have audio, and now we've got external audio, but we made it work, and I think that is testament to ingenuity, and that's what it's going to be all about in the future, that, you know, nothing is going to work according to plan. Well, we hope it does, but there will always be surprises, and when those surprises arise, you should be able to solve those problems by thinking outside of the box. So to our international audience that joined us live, we thank all of you. And we had an international panel. We had from the USA, from Hungary, Nepal, and Brazil, and of course, South Africa. We even had 1 or 2 homeschoolers joining us as well. And Daniel managed to squeeze into the other conversation. You obviously saw it on top of the screen and realized how to work that out, which was very creative. There we go. There's a space person waiting to come and join NASA soon. And we thank you so much for your time. And unfortunately, I won't be at H2M, but I wish you the best of luck. And I hope it all goes well.
Thanks, Steve. It's going to be fun. Let's go.
Cool. So I'm going to stop the broadcast over here.